So we're going to quickly review how to solve quadratic equations using the square root method. So in other words, using some sort of square root to undo something that's being squared. So as we go through the examples of this method, there's a few things we'll be able to keep in mind to make sure we can do this method. The big thing about the square root method is there can be only two terms. On what terms are there? There needs to be the terms without the x. So like something like x squared minus 9 has an x squared term and just a number. There's no regular x. Something like x squared minus 3x plus 7 would not be able to work because it has three terms. In other words, it has an x term. So we only can have two terms. One of them is an x squared and the other one's just a number, or in other words, just our c term. And then once we can verify that we only have two terms, we have to be able to get that square, whatever's being squared, all by itself. As we solve, we're going to use some background knowledge, just like the idea of square roots. When we use square roots, what are we doing? And then we also, at one point, will be simplifying radicals. One huge warning before we do anything is we have to remember when we're going to use a square root to undo a square, we have to use the plus or minus sign. Now what we mean by that is when somebody squares a number, whether it had been a positive times a positive or a negative times a negative, the answer is going to come out the same. The answer is going to always come out positive. So when I look at this example here, somebody squared a number and they got 9. So if I undo the square using a square root, I would get x equals, and most of us think that the square root of 9 is just 3, which would work. If I used positive 3 times positive 3, that would also give me positive 9. But because I was undoing a square using the square root, I need to make sure to use the positive or negative sign. Because when the person squared it, they got rid of the sign. So if I'm trying to undo them getting rid of the sign, I need to put those signs back. So whenever you're undoing a square with the square root, you need to use the plus or minus sign. So our first example is asking us to solve x squared minus 9 is equal to 0. So we go through our requirements, and there should be only two terms. We have this x squared number, and then we also have the number minus 9. So there is only two terms, and none of those terms just have a regular x in it. So we're good with that requirement. Now we have to be able to get the square alone. So what's being squared here? Well, that's x squared. And I can get that alone. If I were to simply add 9 to both sides, I would be able to rewrite the equation as x squared is equal to 9. Now once we have the thing being squared alone, right here, the x squared, we want to get rid of the squared by taking the square roots of both sides. We know that square and square root undo each other. But again, when we undid a square using a square root, we have to use the plus or minus sign. So the correct answers here would be positive or negative 3. You could write it in either format. So we look at the next example, and we're supposed to solve 4x squared minus 25 is equal to 0. So we go through our requirements, and there are only two terms. We have the 4x squared, and then we have our minus 25 term. So we can see that there's only two terms, and none of those terms have just an x. So we've met that requirement, and we will be able to get the squared term alone. To do that, we want to get rid of the 25. So I'm going to add 25 to both sides. Rewrite the equation as 4x squared is equal to 25. Now, just based on the exponents, only the x is being squared. I don't want the 4 there. So I want to undo multiplying by 4 by dividing both sides by 4. So when I rewrite it, I get x squared is equal to 25 over 4. So I do have my square alone. Now, once the square is alone, to undo the square, I'm going to take the square roots of both sides. So I get x is equal to, and since I undid a square with a square root, I have to use the plus or minus sign. Now I'm asking myself, what is the square root of 25 over 4? What multiplied by itself twice would equal 25 over 4? Well, I know that 5 times 5 would give me 25, so my numerator is going to be 5. And then 2 times 2 would give me 4, so my numerator would be 2. So my answer is plus or minus 5 halves. Next example here, we're going to check to make sure that we can use square roots. There are only two terms. We have x squared and we have a minus 6. Now we do see the existence of this other number. However, when I think about my next step, can I get the square alone? Which I can by adding 6. It reinforces that once I have the square alone, the other side is just a number, so there really are just two terms. So I have the square alone, which is my goal. So once I have the square alone, I'm going to undo the square using the square root. So those cancel, so we get x, and I know whenever I undo a square root, or a square with a square root, I have to use a plus or minus. We're taking the square root of 24. And of course, we'd always have to simplify that answer. We don't want to leave it as the square root of 24, so we're thinking about what two factors does 24 have, and one of those is a perfect square. So 24 is the same as 4 times 6. So the correct answers here would have been plus or minus 2 square roots of 6. Now this one just offers a unique example. So the first thing we need to look at is, are there only two terms? And the idea here is on the left side, there's actually only one term. All this stuff has been grouped together by the parentheses. So we don't have a term that just has an x in it. Now this is a special case because what we can see is we're supposed to be able to get the square alone. And what we see is like that's the only thing on the left side. On the left side we have the quantity x minus 3 being squared. So there's nothing else on that side. So this one's actually already set up for us to just do. So we have the thing being squared. The x minus 3 is being squared. It's all alone on its own side of the equation. So we know from before to undo a square, we're going to simply take the square root. So we know that the square and the square root cancel. So we'd be left with x minus 3. We also know whenever we're undoing a square using a square root, our answer needs to contain the positive or the negative. And the square root of 9 is 3. We can't leave our answer like this, though. We have to describe the x values. So what we've said is this number x minus 3 could be equal to positive 3. Or we also said this number x minus 3 could have been equal to negative 3. Again, this plus or minus sign means two things. So we separate it into two smaller solutions, or two smaller equations, so we can actually get the values of x. So x could be 6, or x could be 0, and that would give us the correct answer. Now when I look at this one, I'm asking to solve using the square roots, but when I first look at it, it has more than two terms. It has an x squared term, and it has just a number c, but this one has an x value. So this one's probably not a candidate for the square root method because there's more than one term, or excuse me, more than two terms. So with this one, I might check to see how it factors, x plus 3 and x plus 4. And when I factor it, I don't see anything squared or anything. So on this one, we would just really have to use factoring. We wouldn't be able to use the square root method because it has a b value. And if I did write it as a factored one, it's not like a special factoring where something's squared. So we wouldn't use the square root method on this one. The final example is a little bit tricky, but the idea with this one is some of these special trinomials actually factor a little bit differently than other ones. They actually factor into squares. So when I look at the requirements here, I'm supposed to see only two terms. Like I see my x squared and I see my number, but then I see that it has an x term. So that probably is not a candidate for the square root method because there's too many terms. So I turn to factoring because if I can't use the square root method, we need a factor. So really what we're asking ourselves is when we look at the quadratic, it has a leading coefficient of 1. So we're asking ourselves what numbers multiply to 9 and then add to 6. And what we realize is that those numbers are both positive 3. So if we're thinking about how this factors, we know that this is going to be a positive 3 and this is going to be a positive 3. But that's where like this one's a special case because when we look here, we have the same thing, x minus 3, being multiplied by itself twice. So I could really just write this as x plus 3 squared is equal to 25. So actually, this one, I could use the square root method because I have this square thing all alone. So to undo the square, I'm going to take the square root of both sides. So I'd get x plus 3 is equal to plus or minus 5. I'd write my little two equations. X plus 3 is equal to 5, or it could be the negative one. X plus 3 is equal to negative 5, which would give me the solutions x equals 2 or x equals negative 8. So just a special case there.